All right, in this video, I'm going to continue to cover lecture note 4, okay? So the last time we saw a couple of the commands in mathematical expression, example 2, right? So now, this lecture video, I'm gonna cover all the examples and I'll try to as many as examples in lecture note 4, okay? Because lecture note 4 is quite important to you because you're gonna learn a lot of the syntax and commands to write mathematical symbols, expressions, equations, theorems, things like that. Okay, so it's essential, right? So to write your research paper. So, but I don't think I can cover every single the command shown in the examples. So, but because but so please to look at the all the commands by yourself. Okay, I mean example. So I already I did post the all examples LaTeX file and PDF file in the Blackboard. So please look at that. All right. So see. Okay. So now see the example here. So all right. Okay. So first of all, let's start with the uh the LaTeX syntax array. Okay. So as you can see that here, how can you write the matrix or piecewise functions? So we use the syntax array. Okay. So right there. So it's, give me a second. Begin. Okay. So array. Okay. See, if we're doing that, we need to use, let me see, a is equal to, okay, and then the left, we use left, okay. See that here, this one, the left and the bracket, that will give you the matrix notation, okay. So left matrix notation, okay. So begin array, okay, and then we put we have to set the justification of the each columns. Let me say so C. C means center. Okay, so and then we have this matrix has 3 columns, so I put the 3C. Okay, and now then we say A sub 1 1. Okay, and A sub 1 2, and A sub 1 3. Okay, and then the backslash move to next row. Okay, so here the and symbol that separate the column. Okay, and the A sub 2 1 and A sub 2 2. Okay, and the A sub 2 3, and then 3 1, A sub 3 2, A sub 3 3 3. Okay. Now in the last row, you don't have to, this is if this is the last row, you don't have to enter the double backslash. Okay, just leave it and then just end. Okay, and then right close bracket. Okay, so now since this is the array is the one of the mask the environment, so we have to enter this one within a dollar symbol. Okay, but if you want to write this one in displays mode, then we put the double dollar string. So you can see that here we got this. Yeah, let's see. Oh, now next one. And then you can see here many types of borders are available. Yeah, so let's try to you know um, replicate these three expressions. Okay, so a is equal to, let me so say here, a is equal to, and then left open parenthesis, and then begin array minus dc. Okay, a sub 1 1 and a sub 1 2. Okay, slash and the a sub 2 1. Okay, a sub 2 2. The end of a, right parenthesis. Okay, so now you can see that here we got the 2 by 2 matrix with the other type of matrix. Okay, symbol. Okay, so what about the piecewise function? So piecewise function is f of x is equal to. So there are several way to replicate this one, but this one, but yeah, let me show you two way to do that. Okay, so let me, first one is using array. Okay, left, and then keep in mind this is a curly bracket. That's one of the syntax in the LaTeX. So if you want to express just a curly bracket as want to replicate the curly bracket, you have to put a backslash. Okay, so if you just do this, the LaTeX will recognize you're gonna what put some the command, LaTeX command. Okay, so but if you just put the backslash this, then yeah. Now this one, left expression, the negative, and the begin array, and then you can think this is a kind of two what? Wait a second. Mm, we can think of, I think we can yeah, we see that here. We can consider that this is a 2 by 2 matrix. Negative 1, x is less than 0, and then 1 and x is greater than equals 1. 2 by 2 matrix, right? So let me say, and then as you can see that I can say so negative 1, yeah, let me, so here's problem. How, what, you know, negative 1 and 1 and x, those two inequality, how we set, how, how we set the justification of those two columns. Is it left justify or center or right justify? So we don't know, right? So let's just say CC, okay? And then negative 1, okay, comma, right? And x is less than 0, okay? Next, move to next row, and then 1, comma, and then x is greater than or equals. How can it uh, replicate greater than or equals? This one, GE. Okay, this is abbreviation of greater than or equals, okay? Equals 0, okay? And then and array, okay? And then right, keep in mind this here, do we have we don't, this one and that expression, we don't that does, it does not have the what right parenthesis or a bracket, something like this, right? Then we just leave what backslash right, and then we put period, okay? And then we put the print dollar symbol, okay? Then we got the, yes, but give me a second. So I want to express this one in there. Yeah, okay. So because the reason that we got the that f of x, I mean that piecewise function right below the matrix A, because I just put the one empty line. That means move to the next line, right? So that's why. So if you don't, if you just remove the empty line, then you will get the matrix A and then the piecewise function side by side. Okay. So, but look at this, -1 and 1 is not aligned. I want to get the exactly same expression as this, -1 and 1 right there. Then we have to change the justification, not C, but let's say R. Because look at this, -1 and 1, if you just draw the line, vertical line, and then like a table, okay, horizontal line around those two and the entry in the matrix, okay, I mean -1 and 1 and the inequalities, the -1 and 1 aligned on the right just fine, right? So we put R, then L. So okay, then we're gonna get this. So now, excuse me. Next one is yeah. So look at this. Yeah, a little bit complicated, but let's try. So move to the next line. Okay. So L. Give me a second. So here, so that's not the just regular font style. Okay, what is this? This is ELL parenthesis, and then see that here, the upper right arrow. How can I put that one? So we use this is vector. Okay, vector x, comma, and then VEC means a vector y. Okay, that is equal to, and then begin. That is equal to, all right. Before doing that, we put the what? Curly bracket and then begin. Right. So and then it should be think L R. Yes, right. Okay. Because look at this. Look at the sigma, the summation. Those two sigmas, the symbol is aligned, right? But look at the comma on the right hand side here. The comma is not aligned, right? So it should be left justified. Okay, here and then summation is a sum. Okay, SUM means that syntax will replicate the sigma, the summation notations. Okay, and then sub. You see that here underscore and then curly bracket. That will syntax for writing sub-index, right? Subscript. So I comma j equals 1, and then to put what superscript, we put the what correct, right? So and then n, and the f of x of I equals what subscript. What if you got the one single letter or symbol of subscript, you don't have to put that in within the curly bracket. Okay, x of I, that's enough. And then c dot, and then g of y sub I, y sub j, comma. Then move. That's the first entry, kind of, and then move to the next entry, next column. Okay, so this is for any. Do you see that here? That symbol that means in mathematics for any, right? The letter A is upside down. That means for any, right? So in the command in LaTeX is for all. Okay. Then vector x comma vector y greater than equals 0. Okay. So now move the next row. So sum and then I comma j equals 1. Okay. And then n. And then yeah. So you see the actual value. Um, yeah, normally we just put the bracket, the vertical line. We put this, but give me a second. Yeah, so usually just vertical line right here. Okay, right. Oh, by the way, so keep in mind this when you excuse me, um, what the before doing that, yeah, you have to call these package. Keep in mind this. AMS symbols and AMS math and AMS BSY and then AMS CD, okay, AMS font and text. I don't think you need this, okay. So, but basically, 5 package. Please call these import uh those package, okay. AMS math symbol math BSY and the CD and font, okay. Keep in mind this. So back to here. So now vertical line and then f of x of I, vertical line, and then c dot, and then g of y sub j, comma, and then okay, and then vc x, comma, vc y, okay, less than 0, okay, and then end array, and then the right, sorry, right, the period key minus, put the period, and then I put the double string, okay. So yeah, let me so just really, I mean the gap between the the line A and f of x and the L is really tight, right? So let me put B space or B skip 0.5 inches maybe. Yeah, so okay. All right. I think 0.5 is too much. Let me do 0.1 in. Okay. Now but here's one more things. So when you look at the textbook, math textbook, so this in a sigma, the subscript and the superscript is just right below the sigma and then right above sigma rotation. How can you make it? Okay, this question, right? So we use this one. So here to get the subscript and superscript right below the right above the sigma, we put this one. Some it should be this one. We put the limit limit. That's not the limit. The math terminology limit. Okay, limits. Here, then you will get this. You see that? Okay. So now next one, there is other way to replicate the express the absolute value symbol instead of the just vertical line. You put the L VRT, okay, and then RVRT. Right. So and then let me change this one to okay, L VRT and then all VRT. See, there's no big difference between them, okay? But the sometimes if you put in too yeah, if you use paper has too many math symbols, and then it's hard then so that it's hard to backtracking, then instead of using you know the just vertical line here, because it's hard to catch that. So instead of using just vertical line, you just command LVRT, RVAT each to catch that. Okay, so now next one, yes, I forgot to mention that the other way to give me a second, right, to express the piecewise functions. So here, the other way to express that is this. Give me a second here. Is this using the cases? What I mean is this. So f of x is equal to, okay, and then begin cases. We use the cases the environment, okay, -1, okay, and -1, comma, and x is less than 0, and then 1, comma, and x is greater than or equals 0, and cases. You got this, okay. But here's a question. Here's look at this. -1 and 1 are not aligned, right? So how can you do that? So we put give me a second. See, give me a second. So here you can change the position of the end symbol. Okay, so you can change the, for example, instead of putting this, so you can put negative end symbol is right there here. So you change the then you're gonna get this. But I don't think this is has good shape, right? So that's the one of the disadvantage of the cases environment. Okay, so for this special case of piecewise function, I recommend to use array instead of cases. Okay, so now next one. A second. Let me see. Oh yeah, right here. Okay. Okay. So, but the using what you can see that personally, I prefer to use AMS math package and the matrix command. So there is a short. I mean, the matrix environment, so that you can replicate any type of matrix without using array. Okay, so because using using the array to replicate a matrix, so it's kind of a little bit complicated, right? Using the left command and the right command and the array, and then right. So the um, the easier way to replicate matrix, just use matrix environment, okay, in the package AMS map package, okay. So but these commands, you see, you can see that here matrix just give just matrix without matrix symbol, okay. B matrix bracket, P matrix just parenthesis, V matrix is vertical line, right? And then capital letter V matrix give a double vertical line. Just it's called kind of norm determinant, right? Okay, so I'm not gonna try this. Just just look at the this example, a LaTeX file in the Blackboard. Okay, so now next one. Note that any mathematical expressions can be the entry like this. Let's try to replicate this. So give me a second. This one, yeah. So now here. Okay, give me a second. See. Okay. Yeah, so let me use this one. Oh, yeah. Where is one? Give me a second. Mm. Oh, not this one. Here. Yeah. So let's see. Start running. Let me make this one in display mode. Okay, so begin. Okay, let me use B matrix. Okay, or yeah, let me use array. Okay, B matrix. We can use a B matrix. Okay, see B matrix right there, or you can use array. Either one just fine. But let me use array. Okay, because when you look at the LaTeX file of this example, um, I replicate this one using the B matrix environment. So let me use other way. So left bracket and then begin array, and then how many columns? 1, 2, 3, 4, right? Now the integral symbol is int. Okay, the subscript 0 and the superscript 1. Okay, in the e to the x, the cosine, sine, any trigonometric functions, the log functions. I mean, explains log functions. Don't just write COS. Okay, it's called the log-like functions. Uh, the operators, you have to put a backslash. Okay, cosine and then x, and then the comma, the backslash comma. Remember that, the dx, and the x square, and the plus 1, right? And then triple c dot is what? So c dots, right? And then fraction is d frac, right? Dx, and then sine square x, the next row, right? A sub 1 square, then square root. This is the fourth root, so we put the 4 in the bracket, and then x square plus 2, and the c dot, and then 1. And then now see vertical dot. Okay, v dots, right? And then diagonal dot d dots, and then 0. Go to here, 1, 2, d dots, and then 4, and the array, right? The bracket. Okay, so we got this. So, oh yeah, I forgot. See, forgot to put the n symbol right there. So we got this. Can you see that here? Oh yeah. So I forgot the n symbol right there. Yeah. Okay. So, but how can you give me a second. Yeah. Here's what yeah, I told you you can replicate this on using B matrix environment. Okay, try it. Okay, for example, just try to both. Problem: the correct LaTeX syntax to build the vendor mode matrix. This kind of matrix is called vendor mode. So vendor mode matrix is what? What's the pattern of the entry? So each columns, you see that here, each column just for each columns, the each row, the exponent is increased for exponent degree is increased, right? As the row is increased. Can you see that one? For look at the first column, 1 x1 x1 squared x1 third power x1 fourth power. Okay. So this kind of matrix is called the Vandermoor matrix. Okay, so now so yeah, just try. Okay, please try to replicate this matrix by yourself. Okay. Okay, so if you just then if you just couldn't figure out or got error and you couldn't figure out that, just then look at this LaTeX file, this example LaTeX file. Okay, so let's move on to the next example, matrix expression example. So give me a second. Sorry, by the way, yeah, how can you make the, by the way, so how can you make this a big the the box. We learned that, right? You just use a frame box or a mini box, okay, or a power box, okay. Just use that. So we learned this one in lecture note 2, right? So please refer that lecture note 2, okay. All right. So see example 3, a multi-line environment. Okay, so here, many times it happened that the equation is too long to fit on a line, or for example, there is a natural sequence of several steps in a calculation, and you'd like to display each step. So in such cases, it's good to have a multi-line environment. So the main one that is built in the LaTeX is EQN array environments, but better ones are available if you use an AMS package. So the general syntax for EQN array is as follows. So yeah, so so look at this. Let's see here. If you want to write down this multi-line, equations, then normally we use EQN array. Okay. Uh, Mm, but if you want to use the some syntax in the package AMSMS, then there is a line environment. Okay. So the big difference between a queue array and then a line is, you can see that here EQN array, there are two and symbol is involved here, but a line, just one and symbol is a line. So if you use a two and line here, then you see that here there is a, I think what you see, I think more than two spaces between and equal sign, right? But there is no big space between f and equal sign, the sign, right? See, left hand side, right hand side. So let's see. Let me try. But by the way, what's a 2x? Okay, this is the double space. This gives just double space. Okay, so now, yeah. So since this LaTeX command is shown in the example right there, so try by yourself. Okay, so but let me replicate those two uh, equations. So this one, let me replicate this one. Okay, so g of x. Let me start from now this one. Begin. Let me say align. Okay. Now, and then f of g of x is equal to cosine x times tangent square x. But this is actually what? The rational function, right? So cosine x times tangent square is a numerator, so I put that in the first, in the fraction frac syntax, okay? And the x minus 32. Okay, but we put inside right here. Then to the next line, and then that is equal to sine square x tangent x minus 32. So last line, we don't enter the double backslash, okay? So just end. So now you see this one. But here's a question. Then when you look at this, there is no equation number, right? So we got the equation number. So if you move the equation number for all lines, we put the star. Okay. But if you want to just the remove the equation number in the sum of line. For example, I want to just get the assign the equation number first line, but I don't want to get equation number in the second line. Then we put this here, no number. So just type no number, um, in at the end of line where you don't want to get what equation number. Okay. So here's a question that I want to refer the equation number one. Okay, how can you do that? We put the label. Let's say EQN um, 1. Okay, for example, label. So now, when you call this one, the rational function, the EQ REF, EQN. Well, normally REF, but for the equation, we put the EQ REF. One, this function can be simplified as something. Okay, so let's see. Now, sometimes, yeah, you may have to compile LaTeX multiple times. Okay, so see that the rational function. Yeah, this is called cross-reference. Okay, we're gonna learn this one later, other lecture note, but I just let you know only. You see that function one? So we don't just put the manually just one and then write the one, okay? Because when you write research papers, then you have to you may maybe it happened. I mean, probably it happened that you just get so many equation numbers. It's almost impossible to track them. Okay, so then we use this one cross references. Okay, so keep in mind this. If you just use your REF, what happened? Okay. Then use one. There's no the parenthesis, right? So you put the parenthesis right here. You have to manually enter the parenthesis. Okay, but normally I don't like it. I prefer to use EQRF. Here's a question. Um, the I want to get just I want to assign the equation number in just first line, second line together. Okay, and how can you do that? We just do this instead of this. Oh, give me a second. Give me a second. All right. Yeah, let me write in this one in new line. Okay, give me a second. Okay, now you see that here. I typed the begin EQ and array and the begin aligned. So keep in mind is this aligned environment can be used within math environment. Okay, so because EQ and AR AY, this is a math environment, right? So one of the math environments. So align here. Okay, so now you see. By the way, look at the here. So we got the equation number 3, not just first line, not but second line, but for both line, right? Okay. And I remove the no number right there. So look at this. I mean, look at that. Oh, yeah. So look at this. So I remove no number. So we got the equation number for the second line, the first g of x. For second g of x, we got just only one equation number for first and second, right? So now then, if you don't want get the equation number 3, then we put the EQ and aligned and star. Oh, sorry, not EQN. EQN array. Sorry. Okay. All right. So now then, next one. All right. So here, then give me a second. Let me put EQN here. Then how? Yeah. So now let me get the equation number for the second g of x is 3, right? So I wanna refer that equation number. Then how can I do that? We have to set label. So say label right here. EQN and 3. Now then, the rational function can be simplified as something. Okay, dot dot dot, and then now the another, for example, rational function REF and the EQN and 3, okay, is equivalent to EQN, EQREF, the EQN 1 and EQN 2. What is EQN 2? Let me set assign the equation number 2 in the second line, the first row of x. So LAVL EQN 2. You see that here? Okay. So now next one, no here, yeah. So okay, so now let me skip, replicate this function. Okay, so I think we don't have to use a line or equine array to replicate this one, that function. So just use dollar symbol. Okay, that's enough. Now next one. Okay, so so let's see another. Here's note. The last line, you do not include the double backslash. Keep in mind this. Okay. Next one. Notice the environment automatically put in on equation number. If you don't want them used, if you want them the use, then use this one. Star. Put star. Okay. Then you can also use no number to cancel number on a single row. Yeah. The align environment has many variants. One is that you can set multiple alignments tab. Okay. In this case, the end doubles as a mark for the alignment point and as a column separator. Yeah. So give me a second. Let me see. Yeah, it goes like this. You see, the first end marks the align point of the first column. The second end is column separator. And third end mark is alignment point of the second column. All right, so the key mind is EQN array. It's just has only 2 columns, okay? But using the align, you can set multiple columns. Okay, so this is the example. Let's see. If the number of columns is 3, then there must be 5 ends in each line. The 2 even numbers ends are column separator, and the odd ones are alignment marks. Okay, let me do this. So I'll explain this one by replicating that multi-line equations. Okay. So here. So now next one. Begin align. Start here, and then f of x. Okay. So end. Okay. First, look at this. The first end marks the alignment point. I mean, every odd. See that every. So give me a second. Well, other ones are alignment mark. So this is first end mark must be alignment point. Okay. So that is equal to x plus yx. The second end mark, every even number the end symbol is column separator. Okay. So we move to second column, the g of x, and then we put the what alignment what alignment mark. Okay, point. Alignment point, sorry. So this end is equal to x square, right? And then plus 2xy, and then plus y square. Okay. And then we put the, yeah, what about next one? You see that this is not equation number, right? So how can you, insert those symbols? If we use this tag, using that command. Oops. And then, give me a second. Then AST, okay, close curly bracket, next slide. Okay, so now next one is equals. So that's the first end symbol is alignment point, right? That is equal to x times 1 plus y. Next line, and then and equal to. Look at this. The give me a second. F of x. Yeah. So give me a second. Yeah. So this one is a column separator. So we move to second column. And then since g of x, but in the second line, row, second line, there's no the symbols. I mean, there's no expression left inside of the equal sign. So we put empty, leave as empty. Okay, and the and symbol equal sign, and the x plus y square, and then tag and dagger. This is dagger. Okay, and the end line. And what about the this one? Three columns in multi-line equations. So we use this one. Begin line. Okay. All right. So give me a second. Line. Then f of x and equals ax plus m and g of x ax squared plus bx plus c and h of x a ax 3 bx squared plus cx plus d. Then tag ast that is equal to the x plus 1. Let me align and the marker 2. And that is equal to x squared plus x plus 1 and that is equal to x cubed plus x squared plus x plus 1. Okay. Then TAG and then DAG and align. So yeah, we see. Now, next one. Let me see. Give me a second. Now, next one. Another variant is the aligned environment, which makes a set of aligned equation. Yeah, I did that, right? So let me skip it. So aligned, I just show you, right? Aligned environment, which makes a set of aligned equation into an object that is treated as a single large symbol. Yeah. Next one. Note that the equation environment is the main way to display a single equation with the equation number. Other than the equation number, it is the same as using double dollar sign. Yeah, so equation environment, begin equation, you know, in equation, that's the main way to display a single equation. Okay, keep in mind this. Equation. right? But so as you can see that here, this one, two, if you wanna treat the two lines, multi-lines as one single math expressions, you gotta use aligned, okay, not equation. Now, next one. To put in a line of text between a line row, use the intertext command. Yeah, so let me see. So by the way, so this one, uh, look at the yeah. Just please try to replicate these expressions. Okay, two line math expressions. Okay, and then try and then the what and then just compare your expression, your syntax, like you simply compare your LaTeX with the LaTeX of these examples. All right, now next one, intertext example. Let's see example of intertext. So you see that here, f of x equals x plus yz, and then g of x equals x plus y plus z, and then you see h of x, f of x, g of x, h of x, k of x. These four equations aligned, right? Kind of f of x, h of x are on the first column, g of x, k of x are in the second column, right? But there is a text between first and second row. So how can he insert those paragraph or sentence word between rows? Okay, then we use intertext. Let me show you. So begin. Uh, we use let me use align. And I don't want to guess. Yeah, so again, okay. So now then the align. So f of x n equal to x plus yz n g of x n is equal to x plus y. You don't have to put a single space between the letters. Okay, you don't have to do that. The reason that I do because the because I want you to see clearly. Okay. Next line. Now and then we put this intertext. So the reader also may find the following polynomials useful. Then close curly bracket. And the h of x now we continue writing equation. It's equal to xy plus xz plus yz. Okay. And k of x equal to x plus y. Okay. And the x plus z, y plus z. Oh, I forgot to put equal and symbol right there. Alignment point, right? Yeah, let's see. Yeah, then you got this. But we got the equation number too. Oh, that should be lowercase x, right? G of x. Give me a second. Not this one, g of x. Okay. If you don't want assign the equation number, then you put star mark over there. It's called asteria mark, right? So here, by the way, so here AST means asteria. Okay, yes, it's not. Yeah, so it's kind of nickname of this one is a star, but it's not official name of this. This is asteria. It's called. That's the name of that symbol. Okay, so asteria, the backslash AST. That's the syntax of the asteria symbol. So now let me see here. Next one, and then well, how many? Okay, almost done. So, uh, just hanging there. So one final, the multi-line tool is the multi-line environment. So what if one line equation really long, so that we have to split the one long equation as in the multiplies. So multiple the part. Okay. So we use a multi-line. So let me replicate this one. Okay. So begin multi-line. Um, so multi-line and then end the multi-line. So now then x. Let me see. X of 1. I mean, this is really long, so let me just shorten that expressions because we don't have enough time. So x of 1 and then x of 2 and then square and then move to the next line. In multi-line, yeah, there is no alignment point options, alignment column separator options. Okay, so we just use there is only one option: move to the next line, double backslash. Okay, so now and then x of 3, x of 4, x of 5, 3, and then plus. I mean plus right here. Okay, and then move next line and then plus x of 6, x of 7, x of 8. That's it. Give me a second. Mm, yeah, MULT. So it's typo. Give me a second. MULTLINE. It should be MULTLINE. It should be right. Oh, give me a second. All right, so use this, the MULT and the LINE, so multi-line, the star, okay? So use this when you're gonna get, then you can replicate this one, okay? So by the way, so my, the, I think my laptop got problems. It's just, my laptop is down, see? So let me stop here. Okay, so I'm going to continue to cover the examples in lecture number 4, okay, in the next week. Okay, so all right, so any questions, leave message in discussion board or send email to me. Okay, so let me stop here.